Hello everyone, myself Dr. Sree Lakshmi, Assistant Professor in the Department of AIML at Institute of Aeronautical Engineering. In this session, I am going to discuss about Newton-Raphson Method, which is used to find out the root of the given polynomial equation. And these methods are very important. We can use these methods in real-time applications to find out the roots of the given polynomial. This Newton-Raphson method is also known as Newton's method, and it is an iterative numerical method used to find the roots of a real valued function. The formula is named after Sir Isaac Newton and Joseph Raphson. So together, the method name given as Newton-Raphson method, as they independently contributed to its development. And here, this is the graphical representation where we will find out the initial roots as x0, x1 and x2. And using f of x0, f of x1 and f of x2, we will find out the tangent, and then wherever the point lies in this tangent, that gives the root value, or that gives the required root value. And here, this is having advantages as it is quadratic convergence. If the initial guess is close to actual root, then it is very fast compared to other methods like bisection or secant method. And this is efficiency is more. This efficiency will be occurred with few iterations and are usually needed to reach a high level of accuracy. Beneficially, for complex functions, this Newton-Raphson method is used. And applicability, it can be applied to a wide variety of functions provided the function is differentiable. Whichever function is given, it is fine, but it should be differentiable. Then we can apply this Newton-Raphson method. And fourth one, precision. The method can achieve a high degree of precision when compared with the other methods. And disadvantages for the Newton-Raphson method, initial guess dependency. If this initial guess is not approximate or not near to the actual root, then more number of iterations need to be considered. Requirement of derivative. We need to very much concentrate on the function given. If the derivative is not present, that is, for example, if you take x square, then you can use this function as f dash of x is equal to 2x. It is possible. If you just take x, then for this, the derivative is 1. For some cases, there will not be the derivative properly. So, iterations cannot be done. We cannot find out the root value. Possibility of divergence. If the initial guess is not close to the actual root, the method might diverge. That is, the method will be deviate. And also, if the derivative at any iteration is 0, there itself we need to stop the method. That is, the method will become inefficient. Non-global convergence. It may find a local root, but there might be other roots that are not found if the initial guess is not in the right basin of attraction. See, all the disadvantages are based on the initial guess, and then this should have an iterative. Based on the derivative, we will move on to the iteration steps. If the iteration is 0, then this Newton-Raphson method will become inefficient. And complexity in implementation. For functions that are complex or having multiple roots, this Newton-Raphson method is difficult to apply. So these are the advantages and disadvantages of Newton-Raphson method. And now coming to the algorithm, how we will find out the root of the given polynomial equation using Newton-Raphson method. So here is the equation given x cube minus 4x minus 9. Now, for the first step, we need to find out the initial guess. So here, f of 0 is, that is x is equal to 0, f of 0 is minus 9. X is equal to 1, f of 1 is minus 12. X is equal to 2, f of 2 is minus 9. X is equal to 3, f of 3 is 6, which is a positive value. And this is a negative value. So now the initial guesses A and B are A is equal to 2 and B is equal to 3. Now from this, you can find out this x0 value, whichever it is near. You can consider 6, that is directly you can consider x is equal to 3. Or you might be considered that x is equal to 2, even that is possible. But here, when we are unable to choose which route need to be, which initial guess need to be selected, there is an option that you can go with arithmetic mean. 2 plus 3 by 2, that is 2.5. Average, you can take average and then you can continue. Or else x is equal to 3 you can take, or x is equal to 2 you can take. So now I am going to take x0 is equal to 2.5. This is my initial guess. And now step 2, as per my given formula, xn plus 1 is equal to xn minus f of x by f dash of x. This is my Newton-Raphson formula. And here I required f of x and f dash of x. Here f of x is given x cube minus 4x minus 9. And f dash of x is 3x square minus 4. F dash of x is how much? 3x square minus 4. Now, for the first iteration, n is equal to 0. This is step 3. N is equal to 0. x1 is equal to x0 minus f of x0 by f dash of x0. So, we are having f dash of x and f of x. x1 is equal to x0 value, I am going to take 2.5. So 2.5 minus f of x0, that is 2.5 whole cube minus 4 into 2.5 minus 9 divided by f dash of x0, that is 3 into 2.5 whole square minus 4. So where x1 is equal to, after calculating, you will get 2.593. You can round off this value up to 3 decimals or up to 4 decimals or up to 2 decimals. So I'm going to round off this value up to 2 decimals. So now initially x1 is equal to 2.593. This is my first iteration. Now second iteration, n is equal to 1. For second iteration, n is equal to 1 means x2 is equal to x1 minus f of x1 by f dash of x1. So from here, x1 is how much? 2.593 minus f of x1. As we know, f of x is x cube minus 4x minus 9 and f dash of x how much? 3x square minus 4. So now substituting this x1 value, 2.593 whole cube minus 4 into 2.59 minus 9 divided by 3 into 2.59 whole square minus 4. So this value is equal to 2.597 x2. Second iteration 2.593. If you see, my first iteration value is, that is x1 is 2.593. If I take up to 2 decimals, then I can stop here, because I got 2.59 here and again I got 2.59 here, so I can stop. But I am going to consider here up to 3 decimals. I need to move on to the next iteration also. Based on the decimals we consider, we need to move the iterations. Now I want up to 3 decimals. So now n is equal to 2. That is third iteration. Third iteration, when n is equal to 2, I will get x3 is equal to x2 minus f of x2 by f dash of x2. So which is equal to 2.597 minus, substitute in the function, 2.597 whole cube minus 4 into 2.597 whole square. Sorry, there is no square. Minus 9 divided by 3 into 2.597 whole square minus 4. After substituting all the values in the equation, in the calculator, you will get the value as 2.597. Up to 3 decimals I am going to take. Only up to 3 decimals. Might be you may get 4th decimal, 5th decimal, 6th decimal. I am going to round off here up to 3 decimals. So if you observe here, x2 and x3 values are same. x2 value is 2.597 and x3 value is 2.597. If you repeatedly do the same thing, then you will get, that is at 4th iteration also, you will get 2.597. So now we can conclude that the root value of the given function f of x is approximately equal to 2.597 up to 3 decimals. This is up to 3 decimals. If you take up to 2 decimals, for second iteration itself we got the value as 2.59. As per the decimals increased, the iterations might be increases. And the content is taken from SS Sastry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.